Yeah, no problem.
So, very good evening to all of you. Hope you're able to hear Dr. C.P. Ravikumar as well as me. Can you just confirm once? Good evening, Tapan, Sujit, Somshekhar, Shatruk. We have a lot of students joining in. We will give 3 to 4 minutes for participants to connect, because they take few minutes to join in, and then I have few slides to share. After which I will open the sharing with our speaker today. Then over to him to take over the session further. Okay. So good evening, all of you. People are still connecting. Hope you are able to see my screen. Can you just confirm once? I have shared my brief slide deck. Okay. Thank you for the confirmation, Gaurav, Rubin. Okay. All right. Yeah. Thanks a lot, all of you. Good evening, Mohammed. Good evening, Jayant. I'm doing good, Tapan. I think our old student. Good to see you. Good evening, Ashwini, Kavita, Mohan, Venkatramanan, Divyanshu. I think people are still connecting quite fast now. We are approaching about 200 people now. Another 2 minutes, we'll wait and then we'll get started. Good evening, Anil, Ganesh, Kokila, Pavitra. Nikilakantappa, Shubham. Okay, so as we wait, I want to ask you guys few questions. One is like, I wanted to know 3 things. Well, whether you are an Emergence student, yes to ex-student or past student, or you are an intern, past intern, current intern, or you are a totally a newbie, right? Okay, you can tell I'm a student or a past student or current intern, past intern, or I'm a newbie. Let me see how is the distribution today. Okay, we have some present interns. Star student, current intern says, Sai Mahesh, past intern, new student, past intern, Emergence current student, newbie says Siva, Ranjani, passed out student says Tapan, passed out student, new student, current student. We have very good mixture because we sent out the invitation to almost all the set of people to whom we can reach out to, because it's not something which need to be kept close, right? We wanted to share this particular webinar and knowledge with as many people as possible. That's why team has reached out to as many people as possible. So glad to see that we have a very good mixture of student who are interns, present interns, past interns, present student, past student, and also we have people who are newly joining in. So thank you very much. May I also know the place from where you are joining? May your place, town, so that we get to know the distribution. Okay, we are Thane, Hyderabad, Bangalore, Thane, Bidar, Bhadravati. We have somebody joined from Netherlands, Ongole, Bangalore, Chennai. So many of you from Bangalore, Gadak, West Bengal, Uttar Pradesh, Bidar, Hubli, Davangere, Telangana, Hyderabad, Nilgiris, nice, Ranebennur, Bijapur, Hyderabad, Ooty, Navi Mumbai, Ahmedabad. Very glad to see that. Bhilai, Chhattisgarh, Jaffna, Sri Lanka. Very good to see Mohan has become a regular attendee, our international student. How about people who are outside India? Do we have our international interns here? Yesterday they attended a webinar kickoff, right? Yeah, we have people from Kenya, says Brigitte Demba. I hope I'm pronouncing it right. Yeah, we have a lot of people joining from, and we have Mazen joining from Egypt. Uh, okay, good to see. I think we are good to go. So let me quickly share a few minutes about some, views about this webinar, and then of course our renowned speaker is here. I'll open it up, and then it is up to you guys and him to interact. Take as much takeaways as possible. So let me put it in a slide mode for a few slides which I wanted to share. So very warm welcome to all of you for this masterclass webinar series. If you look at people who have been with us, our past students, they know we used to organize something called Disha, where we used to invite external speakers who are veterans in the industry, who have been there, done that, and who have a lot of knowledge and experience to share. We have been doing that. In fact, today's speaker, Dr. C.P. Ravikumar, has given us a lecture just before the pandemic started. Okay, we still fondly remember how the world has changed after that particular webinar. So what we have been thinking is over the past couple of years, we all go through so many challenges. We're always thinking like, how do we restructure it and relaunch it? So that's the reason, we decided that we'll make this masterclass webinar open for everybody, whom are a student, or even if you have some friends and relatives who wanted to join and benefit from this knowledge, right? So, and thanks to technology, we are able to launch things online. We can see pretty much we have people joining from across India, very many countries outside the world as well, so that we can share this knowledge, much more broader audience, right? So today we are launching our edition 1 webinar 1. We tend to do this on a very regular basis, so please watch out for our social media channels. We continue to reach out via emails, so you are getting the update about the forthcoming webinar also. Okay. Many of you know, but still it is my responsibility to introduce Emergence. As you know, Emergence is a education technology company. We have been in this particular edtech space from 2003, imparting trainings in embedded systems, IoT, and full stack development, targeting two set of audience. One set of audience, we make entry-level engineers employable by providing the full-time 6 months training program, and we also do short-term free internship programs for college students, which very many of you are already part of it. And the second segment that we focus is on upskilling, where we train people who have work experience and then help them to improve their skills and get ahead in their career. That's what we do. And people who are familiar with us, we are this is our leadership team in Emergence. I'm Jay Kumar. I'm one of the directors in Emergence, and we have Mr. Mubin, who is the technology head, who heads the team of mentors, ensuring the training programs are delivered, successfully. And we have Mr. Mas, who is the founder and managing director of Emergence, who started Emergence in the year 2003. So we three pretty much, part of the Emergence leadership team. And we have a lot of past students joining in. You guys don't need many introduction, but as I said, it's still my responsibility because we have some newbies also joining today, right? And over the years, our focus has been on ensuring that our students work on skills and get placed with core companies who is working on automotive, telecommunications, semiconductors, consumer electronics, and IoT, robotics, etc. So that's where you can see a suite of companies which are hiring our placement oriented core students, right? Again, you guys will know this better, right? So let me come to the point, why these webinars? If you ask me to summarize, right, there have been multiple objectives could be there. If you ask me to summarize why these webinars have been organized, so I would say two M's. Okay, one M I would like to talk about as mentoring, right? Okay, so majority of the times when I interact with students, whether you are an intern, whether you are a student, or whether you're an international student, or you are an Indian student, right? Majority of you are looking for right set of guidance, right? You need a right set of people to come and share their experience, and then show you the guidance and the direction where you can head in your career, right? So we felt this is one major element which we wanted to bring in by hosting these webinars, by having renowned speakers like Dr. C.P. Ravikumar. So that is one major objective, right? So once you guys are mentored or you get some kind of a direction, we'll bring wide variety of topics. Today we are going to start with electric vehicles. Going forward, we'll be bringing more soft skill related topics also. So what happens is when you hear from the people who've been there, done that, you really get the right set of mentoring. So what happens to you when you get this mentoring, or when you listen to these people and watch out these videos even later point in time, is that you get motivation, right? You get a positive motivation to take the right step with respect to your career, whether it is in form of improving your skills or choosing the right company for your career, or even for that matter getting ahead in your career by changing your role, or getting into a new technology area and things like that, right? So these two reasons why we are hosting these webinars, making broadly available to all of you, right? So mentoring and motivation are the two important factors for which we are hosting this webinar. Okay, does that sound exciting, guys, to all of you? The mission or the goal of these webinars? Can I get some responses to remember easily, right? Mentoring and motivation. Sashmita says yes. Okay, we have Brigitte, we have Sai, Kamlesh, of course says Abhilash, and then Mohan, Krishna, Sanjay. A lot of people are responding. Okay, so thank you very much for your response, right? So let me go to today's webinar. So today's webinar, as you all know, it is about the electric vehicles, right? It's a topic we have coined it out. In fact, it is suggested by Dr. C.P. Ravi Kumar himself. It's about the emergence of electric vehicles, opportunities and challenges, right? As you know, electric vehicles are being the talk of the day, especially countries like India, where we have opportunity to basically lead the electric vehicle revolution, especially when it comes to the two-wheeler segment, right? We have already companies like Tesla who are ruling the electric vehicle space more on the four-wheeler side, and we also talk about what you call the self-driving cars and all in the countries, the developed countries in the West. But when you look at countries like India, which is densely populated, and also where there is more opportunity for us to innovate in terms of two-wheelers, we have a tremendous opportunity to innovate around electric vehicles, right? So we have two suite of companies. One suite of companies which are new age startups, companies like, for example, Ether Energy, Ola Electric, are all getting into this foray of electric vehicles. And we also see the traditional vehicles, right? The traditional companies, for example, Bajaj, TVS, and Honda. Again, as we start the webinar today, we have a sad news to share, right? Mr. Bajaj, who is the founder of the Bajaj Motor, has passed away a few hours back. I don't know whether you saw the news or not. Even those companies are going through transformation to make them as an electric vehicles, right? So again, electric vehicles is a combination of multiple technologies, and where embedded systems, IoT, and a semiconductor comes into picture, right? We wanted to understand. So that's what today's topic is going to be, right? And I just wanted to set how this is going to be structured. In few minutes, I'll share the Dr. C.P. Ravi Kumar will start sharing the screen, and he will walk you through the set of slides. And as and when you have questions, as we already always do in our immersive webinars, you can type it in the screen. Unfortunately, he may not be able to see them. I can read out and he can answer the queries, probably in a logical intervals. That is one thing. And all the participants, just to make it more motivating for these sessions, all the participants today will get participant certificate, right? Our team will email you in the early next week. Once we have the list of attendees from today's event, we'll give you a certificate, right? And to make it all the more interesting, we'll also give you a quiz and goodie, right? The quiz will go live by end of the webinar around 9 p.m., 8:30, 9 p.m. Whenever it gets over. I'll announce it in the webinar itself, and it will go live in our Instagram page, right? And just to ensure that only webinar students take up this quiz, I will be sharing you some kind of a coupon code or a QR code, whatever you can call, which you can put it in the quiz, and then you will be able to take it further. Because we have about 6,000 followers, we don't want anybody external people to take up the quiz, right? We want only people who are currently in the webinar only to take up the quiz. So once you take up the quiz, you can submit your answers, and again our team will evaluate, and they'll be shipping you goodies, in the next week, right? So just to keep us a little bit excited and motivation, right? So those two are the takeaways for you. So it's been my privilege to introduce today's speaker. Dr. C.P. Ravi Kumar is a technical director of university relations at Texas Instruments India. Texas Instruments doesn't need any introduction, right? It's been a pioneer in the semiconductors and chip design over the past decades. And he also heads the TA India Technical University, which provides learning opportunities to employees of TA India. So what I see, Dr. C.P. Ravi Kumar's profile, just going back, right? So before he started taking up this role with TI. He spent about a decade as a professor in electrical engineering in a prestigious Indian Institute of Technology, Delhi, between 91 and 2001. And before he went into the academia, he spent a good amount of time doing his research in computer engineering from University of Southern California, what you call UCSC. And before that, he has got his master's from Indian Institute of Science. Again, people know this is it's a top-notch institute from India. And then he's an electronics engineer with gold medal from Bangalore University, right? So he's been a great profile. You can see a top-notch student becoming a researcher and a professor, and then coming to the industry, and then leading the education programs and the technical skill development programs of Texas Instruments, right? And even though it's been he's been very active. He's published over 200 papers, written about 12 books, and he's been very active in the IEEE society and driving a lot of initiatives. And more than anything else, what I personally like about sir is that he is very humble and probably very approachable to all of us. So thank you very much, Dr. C.P. Ravi Kumar, for accepting our invitation to share your learnings, your knowledge with our students, interns, and our new people who are registered us. So it's been a pleasure having you. So on behalf of Team Emergence, I would like to thank you. So what I'm going to do is, like, I'll just share I'll make you as a presenter, and then maybe you can come on the video, and then you can take over from here, sir. Are you able to see the share button, sir?
Yeah.
Okay. Yeah.
Okay, so first of all, thank you very much for the kind introduction, and it is my pleasure. I hope I am audible. If there is any problem in the audio or something like that, please do let me know. So let me sort of, I believe already Jayakumar has introduced me. So he has been very kind in introducing me. I have known him, I think, for maybe about 3 years or 4 years now. We used to meet in a sort of a, I think the government of India had some sort of a initiative, and we both were part of a committee, and that is where we met many times. And like he said, I have visited your office, and I have given a seminar earlier also. And it is my pleasure to once again be part of your webinar series, right? So thank you for having me. And so let me begin by sort of asking you, right? All of you are engineers. Many of you are probably finishing engineering. Many of you may have already completed your engineering, and you may have started working, or you may be looking for jobs and things like that. See, when the pandemic started, we used to see on the social media so much of the sort of thank yous for medical professionals, right? Everybody used to say, thanks to medical professionals, we are able to face this pandemic and things like that. But engineers, they have contributed equally, if not more, in making life bearable during the pandemic. And as engineers, we should all be very proud of ourselves. So let us look at, how all these, inventions have paved the way for all the technology that you saw at play during the pandemic, right? Imagine, if we did not have laptops today, and if computers were not part of every home, right? Or if mobile phones or smartphones were not part of every home, then life would have come to a standstill for many of us, isn't it? Today, you are able to view this webinar because of your mobile phone or your laptop. You're able to stay connected with the world thanks to the communication and the computing technologies that we have available, right? So the entire revolution began, I believe, in I think 1950s itself. A lot of groundwork was done, and I don't know whether you remember the year in which the first IC was invented, right? It could have been a good quiz question, but I'll give you the answer. 1958 is when the first IC was invented, right? And since then, the world has not looked back. Okay. Initially, with the IC, they started making what are called as small scale integrated circuits, and soon that paved the way for medium scale integrated circuits and large scale integrated circuits. And by around mid 70s or so, already we had the first microprocessor. And when I was a student like you, in 1983 is when I graduated. At that time, already these microprocessors had just made an entry. 8-bit microprocessors were very popular at that time, and the computing revolution had sort of begun, right? And the computing revolution was then followed by the communication revolution, right? So when I say revolution, it was the computer was the sort of killer product, as you can say, right? And laptops and desktops continue to be, and of course servers, continue to be killer products even today, right? Um, so that computing revolution slowly led to the second revolution, which is the communication revolution, right? And in the computing revolution, I think Intel was sort of at the forefront because they had the microprocessor business, and that was very central to this desktops and laptops and servers and so on, right? The communication revolution, right? I guess TI had a very big role to play there. See, the mobile phone. See, at one time, people did not know that it will be possible to put, this basic things that are required to build a phone, right, into a single chip. Okay, what is called as a system on a chip, and make it part of a cell phone, etc. So that TI, I believe, was the first to demonstrate that such a thing is possible. And we were indeed, for many years, almost a decade or so, we were leading that, from the front, the wireless, chipsets from TI, were very popular. And Nokia was our big customer then, and it was a major success story, right? Now, naturally, things don't remain the same, right? Things are always going to change. Communication, mobile phones, while they continue to be important to us even today, but the we need new sort of avenues. We need new markets where we can start activity, right? So that is true for all the industry. So we have to keep looking for new markets, and naturally there are questions about what is it that is going to be new. And there were many answers. Healthcare was one thing that people have pointed out many times, right? And also the factory automation or the manufacturing sector, industrial electronics, robots, that has been another big area of development. And today we are going to touch upon automotives. Right? So that has also been a major, developing market. Okay. So during the pandemic, I guess guess all of you have seen that these communication, compare, manufacturing, these technologies, they were what made our life bearable, isn't it? Look at all the healthcare gadgets that were introduced in the market, all these oximeters, pulse, these oximeters, then these temperature monitors or thermometers, remote thermometers. Virtually every organization uses, many homes also have them, right? Like this, a lot of medical gadgets, made their appearance, and they became popular. And I already talked about communication, right? Today, we rarely have to go physically to do any activity. Like, many of us may not even go to a shop anymore. We just do online shopping. Many of us may not physically go to a bank anymore. We just do online banking. Similarly, theaters have closed down for a lot of, I don't know that maybe now they are open, but I don't think people depend on theaters the way they used to depend once upon a time. People, and now the theater has come to your homes, right? So like that, today we are living in a sort of a different world altogether, thanks to the technology, right? And we should be proud that despite the pandemic, right, we were able to maintain a semblance of order, right? Of course, we all suffered, no doubt about it. I don't think we enjoyed this period, but it would have been worse if these technologies had not been there. So let us be proud of the engineers who have been behind, I would say they were behind the scenes and making these things happen. So you would have heard about this smart devices everywhere, right? So the three things that have led to smart devices are, one is, the today it is possible to put a lot of instrumentation in our gadgets. So when I say instrumentation, I'm basically referring to the sensors, okay, and also perhaps actuators. So today, you can measure just about anything, right? There are sensors for everything, in a car, I think there are so many sensors. You can start thinking about some of the sensors that are used in cars. See, you will need a sensor for measuring the speed of the car. You will need a sensor for measuring the acceleration of the car. You will need a sensor for measuring the temperatures at various points in the car. You will need sensors to measure the amount of pressure in the tires, right? So all kinds of sensors, okay, they essentially have made a big difference for this embedded sort of computing that goes on everywhere. Even a car is basically, you can think of it as a large embedded computer if you want, or an embedded system if you want, right? The other thing that has happened is virtually everything is connected today. Okay, so when I was a student and I started using computers, see, they were not connected. This networking was not there. So the only way to share information was through these so-called floppy disks, and they were very unreliable. And later, even viruses came in, and it was very painful, right? But today, I think we live in a world where we can share information very, very easily at the touch of a button. We can share information. So and today it is not just humans that communicate. Computers can communicate with computers. Even embedded systems can communicate with other embedded systems. So cars, for example, today it is a big deal that within a car there is so much communication. Okay, cars can communicate with other cars today, so that the driving is safer, right? If you are coming very close to another car, so you can sort of use this vehicle-to-vehicle communication to negotiate, right? So such protocols already exist. Such systems already have been built. Similarly, when a car is passing through, it can establish communication with road infrastructure. There may be some infrastructure, like towers. Maybe there are other servers that are installed and things like that. So you can start communicating and getting information from other infrastructure as well, right? And this has happened, mainly because both wired and wireless connectivity, okay, have become more power efficient, more reliable, more secure, and faster, right? So that has led to this feature, right? And that has made a lot of difference. And the third thing is, now there is a lot of push about intelligent computing, which I suppose refers to the use of massive amount of data that is becoming available, and how to quickly process the data, right? We have invented image processing, right? We have invented video processing, etc. So these technologies are helping us, right, along with the wonderful software that is available, which uses machine learning, deep learning, artificial intelligence, and so on, to do things that otherwise humans used to do, right? For example, if a car is self-driven, right? When human beings drive a car, they are on the lookout for any obstacles that are coming on the way, right? Now the same thing is now being done by software. A software can do that. Okay? Similarly, a software can optimize the parameters of the car. How much fuel to be injected. All that is now being managed by the car. So the three I's, namely instrumentation, interconnections, and intelligence, these are driving the technology today. I would say that the developments in these three areas has has contributed to these smart devices that we see all around us. And see, though we don't like to sort of admit that the world is becoming more and more urban, that is unfortunately the case, right? We may not be too happy about it, but the number of the urban population is steadily growing, because people find that the advantages of living in an urban uh, you know space, nobody can deny that it's much more comfortable and so on. So unfortunately, as more and more people move into urban areas, there are problems associated like traffic congestion, the pollution, the poor air quality, etc. Similarly, even providing basic amenities like good quality water becomes a problem. Electricity, providing good quality electricity becomes a problem. Then there is an increase in slums, and as a result, a lot of hygiene-related problems come in. Then, of course, crime and security become a issue. Okay, and if and there is a natural disaster, and we hear about it all the time, isn't it? See, whenever there is a large rain, right, the cities, the life in the cities comes to a standstill, right? Whether it is Mumbai, whether it is Bangalore, whether it is Delhi, we are not geared for such natural calamities. Like if the rain is beyond some, beyond some point, we are not ready to, our roads become clogged, so problems arise, right? So there are a number of problems to solve. So that is the, as students perhaps, and as engineers, young engineers, the thing about this slide is that it tells you that there is a lot of work to be done, right? We all need to put our minds together and look at what we can do as engineers to perhaps improve the quality of life in the urban areas, right? Because the reality is that the urban population is growing very quickly, right? So that is something that we need to keep in mind. So let us look at the technologies that have, sort of helped us in making some of the things that I'm going to talk about a reality. See, power dissipation, right? If it had not been for low power processors, low power analog, etc., we could not have built these laptops, isn't it? When I was a student, we had these bulky computers, right? And we did not really have our own computers. We had to have terminals that were connected to what is called as a mini computer. And I had to physically go to a lab to use these facilities, right? There was no such thing as personal computer in those days. When personal computers came, that was a big deal, right? But today, we all have laptops that if you charge it, it goes on for many hours. Okay, so this today we sort of take it for granted, but the reality is that unless engineers had invented these processors which run at very high clock speeds, but at the same time they optimize power dissipation. So here is a slide which shows on the x-axis I have shown the year of introduction, and on the y-axis I have shown the milliwatts consumed to offer a performance of 1 million multiply and accumulate. MMAC stands for million, multiply and accumulate. See, this MAC or multiply and accumulate is a standard thing in digital signal processing. Okay? So in DSPs, the higher value of MMAC means the DSP is more powerful. So you can see that this is a sort of, it looks like a linear curve here, but it is actually a, it is a logarithmic scale. See, this y-axis is logarithmic, which means this is actually an exponentially decaying curve. Okay, so when I was a student in 1983, the milliwatts to drive 1 MMAC was huge. It was something like 500 milliwatts, okay, or half a watt. Now it's come down to a much smaller value, right? It is like 10 to the power minus 5 or something like that. Okay, and you see there is on the same curve, if you look at what is called as energy scavenging. What is energy scavenging? See, sometimes we can take out energy from other sources of energy around us. For example, you may have heard about how we can take the wasted heat that is coming out of computers, and that can be harnessed. Okay, or let us say the energy from footfall. See, in a busy area like a bus stand or a railway station or something like that, there is so much footfall. Okay, and that energy, okay, we can set up the sort of there could be piezoelectric energy that is getting generated from the footfall, and that could be powering the entire railway station. Okay, so such experiments have already been done. Similarly, you can have solar power harnessed. Similarly, you can have wind power. You may have also heard about wave energy. So there are so many sources of energy that can be harnessed. Okay, so people are looking for an alternate to the chemical energy. Okay, they don't want to use this thermally generated electricity by which is basically coal, right? Or any fossil fuels being burnt in order to generate energy, right? So this is the amount of energy that can be scavenged. And you see, earlier this energy was so small that it was not very useful, right? But even as early as about 2010 or so, these two curves sort of crossed one another, which means that in the last about 10 years or so, the amount of energy that we scavenge from these external energy sources, right? That may be enough to drive our embedded computers, because they are so low power that they can be sustained on this scavenged power, right? So that is how the world has been thinking. And in the next maybe 10 years or so, you can expect that we will hear more and more about such. Already we hear, but still it is all on experimental basis. But in the next 10 years or so, you may start hearing more about how we can eliminate the conventional sources of power and start depending on solar power. Maybe a day will come when we will have a solar powered cell phone. Maybe a day will come when we have a solar powered laptop and things like that. We are still far from that, but these are all areas that people are sort of working on. This same is true for here. This shows the low power modes. See, in these embedded computers, there is the various low power modes: LPM0, LPM1, LPM2, LP3, M3, etc. So in embedded computers, you must know that there is a slight difference. You are all students, so maybe this may be interesting to you. If you have taken a course on microprocessors, they will ask you to generate a delay loop, isn't it? You may have written a small loop in order to generate a time delay. So the standard thing that is taught in colleges is, you put a counter and you keep on decrementing that counter, and till that reaches 0, you keep on looping, and you adjust the value of that counter so that you can adjust the value of the delay and things like that, right? But frankly, that is not the best way to generate a delay today, right? It is very wasteful of power, because when you are doing that countdown, you are in the active mode. So AM here means active mode. In the active mode, you will consume quite a bit of power. Okay, it may be very small, but still, relatively, it is quite significant. So the correct way to generate a delay would be to sort of program an interrupt controller to interrupt you after a certain amount of delay, and go into what is called as a sleep mode. Okay, so as programmers, you have to realize that the embedded processor designers provide a lot of these facilities like low power modes, and if you don't make use of them, right, then your quality of the software that you are writing is not good. It is wasteful in terms of power, right? So this is something that you have to remember. So you have to use all the architectural features that the processors provide for you. So you can see that in the low power modes, there can be a very significant reduction in the power, right? Another example is, the this C322, is another processor from TI. So this is meant for wireless communication. So if it is going to continuously transmit, okay, so this is the amount of power it will sort of generate or require. But if you go into standby mode, you can see that there is a very significant reduction in power. And if you go to what is called the deep sleep mode, there is a further reduction in power. So the way normally embedded systems are programmed is that most of the time they are sleeping, right? And they respond to any events. Okay, maybe there is an interrupt coming from some device that requires a service. Then you wake up and quickly serve that interrupt and then go back to sleep. Right? That is the correct way to program. Otherwise, see, there is a lot of transistors today on our microprocessors or embedded processors, You may have heard that there are billions of transistors, right? But unfortunately, if you keep all of them active, right, then it will generate so much power and so much heat that it may be destructive. The chip will not survive, right? So we cannot keep the entire processor in the active mode. So we have to manage the power. So this is known as power management. Only some small portion of the total chip will be active at any time. The other things which are not required are all powered down. Okay, they are either the clock is disabled for those parts or power is disabled to those parts, so that we can manage with a little bit of power. So that is a system level opportunity for optimizing power. And as software programmers, you should all remember these things. So there are more examples. Sitara is a processor from TI, which is useful in a number. It's a microprocessor based on the ARM processor. The TI has a microprocessor. Again, you can see that there is a significant reduction in the standby power. It's only about 16 milliwatts or so. Okay. So these are all, and this I think the data I have is perhaps 1 or 2 years old. So by now, if you go and see, this power may have further been improved. Okay, the technology keeps on improving, and we keep on making better processors. Okay, and this shows the various wireless technologies like Zigbee, ANT, and Bluetooth, low energy, and so on. So again, you can see that as you sort of increase this so-called sleep interval, your current consumption or the power consumption keeps on dropping, right? So this is basically the point that you can remember is engineers have built very low power processors, very low power communication chips and signal processing chips, and that is at the heart of the revolution that we see today, the embedded revolution, right? I talked about sensors earlier, right? I think I mentioned the accelerometer, then the proximity sensor, maybe there is the IR sensor, right? Then IR is infrared, then gas sensor. Okay, this may be useful for detecting leakage of gas and things like that. Then temperature sensors, chemical sensors, if there are dangerous chemicals that you are trying to detect, smoke sensors in buildings and so on, motion detectors, right? So there are a lot of the sensors that are required today, right? And the sort of technology has constantly improved and made them smaller and smaller. So today it is very common to use this MEMS technology, micro electromechanical systems, right? So starting from what is called as tube type sensors, people moved to print type and then micro beads, and now they are using MEMS sensors. And these are very small in size. They take very little power, right? Some of them you can't even see with your bare eyes. Okay, so that has been another source of innovation, right? And you see, the systems that we design today, they all have some sort of a sensing unit, whether it could be pressure, it could be chemical sensor, whatever it is. And the sensing units, they bring what are called as analog signals. Okay, these are analog signals, and they must be conditioned so that we can convert them into digital form. Okay, some amplification, noise removal, etc., need to be done here so that we can get them ready for analog to digital conversion. And then here is where your computers work. Okay, they may be embedded processors or embedded computers which take these digital signals and process them. They may apply various kinds of signal processing in order to get some information out of what is happening, right? And when sometimes we may have to transmit that information externally. or to another processor, right? So this is basically how sensor units are built. And the good thing is, you see now the affordability of the transistors have become much more affordable today. So instead of selling only the sensor separately and asking all these to be done separately, now sensors are getting integrated with all these things. So that is why we call them smart sensors. So the sensors are sold along with all these other things, okay, including processors, etc. So we get what are called as smart sensors. So here is a this millimeter wave sensor from TI. It has all these things inside them, and they are sold as these kind of gadgets that people can readily use, right? And these smart sensors are used in a number of places. I wanted to show you a couple of interesting examples. See, for example, this ultrasonic sensing. Okay, it has been used in the detection of sound waves. Okay, so for example, if there is water leakage happening in some place in the building, right, where we don't even have access or something like that, then these ultrasonic sensors can detect the sound of the water, and we can know that there is a particular place where there is leakage happening. Okay. People have also used it for measuring the amount of gas that is flowing through the pipes, right? This is useful when you start introducing, I think India is also on its way to sort of avoid the cylinders being delivered to our doorstep. Instead, we can have gas being supplied through pipes. Then obviously we need a way to measure the amount of gas that we are consuming. So for such things, people are using these ultra sensors. Similarly, here is a sort of a factory building perhaps, where there is a person here who may be transporting some stuff, maybe raw materials or finished goods are being transported. And see, there may be human beings and robots all in the same space, right? And unless we have these ultrasonic sensors, etc., to detect when there are movements of these robots or human beings and so on, then it can be a dangerous situation where somebody, human being, may be harmed by a robot and things like that. So sensors are useful in this industrial electronics area to detect motion and things like that in order to build a more safer factory. Okay. I mentioned the millimeter wave sensors. TI introduced them, and they are very popular. They have a range of about 30 to 300 gigahertz, and as a result, the antenna is very small, right? And they offer a lot of resolution. And the main reason why TI invented was, I think they were looking at the automotive space. So I told you about this vehicle-to-vehicle communication, right? So if a vehicle is moving around, it can sense, whether there are other obstacles coming, including maybe other cars and so on. So for that, these millimeter wave sensors are very useful. And I already mentioned to you about the industrial electronics, how it is being used, right? And so, smart factories in the pandemic period, people are beginning to invest more and more in smart factories, because unfortunately what happened during the pandemic is many factories had to be shut down because the government was introducing this lockdown and things like that. People could not go and work in factories. So at that time, if you have to continue to produce materials, because people will continue to need all those things, isn't it? We all want to use all the things that we buy online, where somebody has to produce them, isn't it? And if the factories are operating with if there are no people or very few people to operate these factories, then a lot of automation is required, right? This includes semiconductors also. So even today, you may have heard about the shortage of semiconductors, isn't it? during the pandemic, because of not full staff was installed in the factories because of social distancing and all that. So factories were not operated at the full capacity. So as a result, there has been a shortage of semiconductor, and we hear about it all the time. Now they are trying to ramp up the productions, and a lot of automation is being used, and smart factory is a big thing. And in the smart factories, a lot of automation is used, robots are used, and then they may use these machine tools with the CNC machines may be there, right? And they may use PLCs to control these machines, programmable logic controllers. And the most thing, you may have heard about this Industry 4.0, isn't it? The Industrial Revolution. Today, we believe that the Industrial Revolution is in the fourth phase. So what is the fourth phase? The use of these computer facilities and the communication facilities that are available, especially with these big data analytics and artificial intelligence. Okay? So a lot of better planning can be done. See, in factories, space is limited, isn't it? And you are planning so many things. You are so many people may have placed orders, and we are trying to manufacture goods to meet those orders. And there'll be some dynamics, isn't it? Somebody cancels an order, or somebody cancels the order after you have started production. So it's a very dynamic situation. You have to start taking decisions as to what to do. Some things have to be moved away, right? Otherwise, already a lot of space is taken by the half-finished goods lying around and things like that. So the space has to be managed efficiently. The machines have to be managed efficiently. So for these optimization problems, right, a lot of these AI-based techniques are being used for scheduling the shop floor and things like that. Okay? So use of these is what is driving the Industry 4.0 and things like that. And so now let us come to the automotive, right? What is new in the automotive area, right? Of course, as I mentioned earlier, you can think of the car as a large embedded system, if you want, right? So what you will find plenty of sensors in cars, right? And you will find a number of processors in cars. The number of processors in a car today will be not less than 100 or so. Yeah, about 100 processors. And what do they do? They are controlling every small thing. If you want to lock the doors automatically, you need small processors to manage that. If you want to automatically roll the windows up or down, you need small microcontrollers to manage that, right? If you want to manage the amount of fuel, the fuel gauge, etc., you need a processor. Like this, literally hundreds of processors are present in a car, right? And see, the traditional car used the internal combustion engine, isn't it? That is how we used to use. But as you know, they consume a lot of fossil fuels. Okay, the petroleum as well as this diesel. They are they result in a lot of pollution, right? When we burn these fuels, we result in this carbon waste. So there is we leave behind a carbon footprint, right? So people are trying to replace them, right? So the first attempt was to build what are called as hybrid electric vehicles, right? Where you will have a combination, right? Both fuel based and electric motor based. Okay. So in a electric vehicle, even the IC engine doesn't exist. So you see all the mechanical engineers they study these IC engines for, I think, many semesters. They study how the IC engine works, etc. But in an electric vehicle, that won't be there at all. There is no IC engine. Internal combustion engine doesn't exist. Instead, we have a electrical motor to control the wheels. Okay, and that is what has completely replaced, the IC engine. Similarly, the traditional car, has been fully controlled by the driver, and slowly it is leading to semi-autonomous vehicles, where some of the functionality is now done automatically, and maybe already, I think, on an experimental basis, these fully autonomous cars have been built. Google, for example, built this. You may have heard about the Google car, and then I think even I think Jay Kumar mentioned, there is a space of smart cars that this many other companies. I think Jay Kumar was mentioning the names of a number of other companies. So this is a new trend, right? So it provides a lot of opportunity. Okay, software has to be written, right, for these autonomous and self-autonomous cars. And do you know how much software is there in some of these automotive, exercises? You can try a guess. Okay, I'll ask you a question. Do you think it will be about 1 million lines of code? Do you think it is about 10 millions of lines of code? Do you think it is about 100? Or do you think it is about 1,000 billions of code? Or 1 billion lines of code? What do you think it is?
So, guys, there's a question from sir, like how many billions of code or millions of software that you feel will be in
Millions.
these vehicles, right? Sir, I'm getting answers. I'm getting, some of them are
Yeah.
telling billion, some of them are telling 10 billion, then 1 billion, 1,000 billion, and some of them are telling millions and billions.
No, no, no.
Just to provide guess, right? I'm getting all the answers
I
here.
think
10
these
billion.
are all.
Yeah.
Yeah. I think I'm told that a modern car may have about 150 million lines of code. It is still not billions, thank God, but it is about 150 millions of lines of code. And you can imagine the complexity of that software also, right? And it has to work correctly, right? So there are a lot of you know things. We'll talk about that a little bit. Then earlier the cars were disconnected. Okay, like I told you that when I was using computers, they were disconnected from one another, and we had to use floppy disks to connect, take data from one computer to another computer. Today, vehicles, you know, uh, you know, they were disconnected, but slowly the vehicles are now connected to the cloud. Okay, what is the advantage? The advantage is you can monitor, where the if Uber or somebody is running a fleet of cars, right? And if they're all connected to the cloud, see, you can monitor every car. You can monitor the speed of every car. If any driver is over speeding, you may have experienced that when you are going to the airport, suddenly there'll be a message saying, you are exceeding the speed limit. So if Uber has to keep statistics about their drivers, they can keep statistics about the driver's habits. Does this person speed a lot? Does this person, sleep off occasionally? Things like that. All that can be collected today. So connecting to the cloud is one big thing. And slowly, they will also go to this connected to other vehicles and other infrastructure, right? So that is where the trends are. And as you can see, all these are huge projects. Okay, these are not, it cannot be done, in a 1 or 2 years. They will require many, many years of effort. So there is plenty of opportunity for you. This is all good news for students like you, that there is plenty of work to be done in these areas, right? And the word ADAS, anybody knows what ADAS means? Anybody can guess what it means? What does ADAS mean?
So there are some answers coming in, sir. Vimal says driver assistance and adaptive systems. Abhilash is telling automatic driver assistance. In automatic driver assistance
Correct,
system,
correct.
how much are getting it?
Yeah,
Yeah,
I
Tapan
believe
and
that
Nikhan.
is
Yeah,
good, good, good. I'm glad to see the
many of them can. Yeah,
participation. ADAS,
yeah.
yeah, ADAS, has traditionally stood for Advanced Driver Assistance Systems. Okay, so in low-end cars also today, even cars which are maybe about 5-6 lakhs, they are providing some form of driver assistance. For example, if you want to reverse a car, they will show the image very clearly so that you can avoid any obstacles when you reverse a car and things like that. And if you have a high-end vehicle, you may have experienced even more assistance to the driver, right? For example, parking. Okay, people, it will assist you in parking the car. In fact, fully autonomous parking is also now available. You can get off the car and it will park itself like a valet parking or something like that. So from one end of the country to another end of the country and things like that.
Um, Ravi Kumar sir, you are not audible, sir. Uh, Hello, guys. You are not. You are able to hear me, right, students? Okay. I think they are able to hear me, sir, but I think they're finding
Now
it
it's
little
okay,
hard
right?
to hear. Yeah,
Now
it's
it's
okay, sir.
okay.
Yeah, it's
Yeah,
yes,
yeah.
sir. Yes,
Sorry
sir.
for the, there was a temporary problem and okay.
Sure,
So
sir. Yeah, go ahead.
as I was telling you, there are these in the US the roads are so good that people drive cross country and things like that. So and they are driving in the night and many times accidents occur, right? People fall asleep while driving. So today I believe cameras can continuously monitor the driver's face expression, and if a person is yawning or his eyelids are closed, etc., etc., there is software available to check whether the person is sleepy or sleeping, and it can warn the driver, right? It can maybe create a noise or whatever, and such facilities have now come. Okay. Also, collision warning about especially in the night driving, etc., and automatically braking to avoid collision. And I believe there is a Insurance Institute for Highway Safety that has done some statistics to say that this ADAS has reduced the amount of front to rear crashes by 50%. Okay, so this ADAS feature is really helping in reducing the loss to human life and things like that, loss of human life. But we have to make ADAS affordable, right? It should not be that only very high-end cars have this and low-end cars cannot have this, etc. But so that is where innovation is required. That is where people like you will have to come up with innovations so that more and more people can use these features because it is more affordable, right? So I think I mentioned to you about how to make vehicles safer. Computer vision, using it to detect obstacles on the way. When you drive in a foggy kind of a situation, then I think these image processing algorithms are very good. Even in the fog, they may be able to detect something even human beings cannot do. Right? In the fog, also they are able to detect obstacles and so on. Speed warning is very straightforward. Pressure sensing, if a pressure in one of the tires is low or high, then it can warn you. Locking the door automatically, etc. Weather warning. Then there is vehicle to vehicle communication. So there are a lot of these features that are coming in to make vehicles more safer to drive and things like that, right? And there are many complex usage scenarios you can think of, like driving in bad weather, raining, it may be foggy or it may be raining, okay, or it could be that you have the road is very bad, or there is poor lighting, or you may have to find parking in a very crowded mall. So you should take these examples. Parking the car in a crowded mall, right? It can be quite a painful thing because you have to first locate where the empty slot is available, right? And today the way it is done is, you go around looking, right? And it can be quite a painful experience, right? But with so many sensors available, cameras, pressure sensors, fuel monitors, etc., these things are becoming easier, right? I think I may have a picture here. It will come up. Okay. So this vehicle to X, V2X means vehicle to everything communication technology, which connects vehicles directly to other vehicles and roadside infrastructure, okay, and to pedestrians via these low latency communication links. Okay. And that is causing people to think about safer travel and this cooperative autonomous driving. That means vehicles cooperate with one another and help to maintain the traffic flow. Okay, it may also help you to reduce the traffic congestion and things like that. So I was going to tell you about this mall parking, right? See, there are some parking slots available here, some here. So if you enter in the beginning, today I think people have to go all around looking for space and things like that. And while you're looking for that space, somebody else may come and occupy, right? So you have to locate a parking spot and guide the driver in parking that, right? So today the ADAS systems that are available can help do that, right? So they will take these multiple camera images coming from different cameras. See, there may be multiple cameras in the same vehicle. Plus, remember that if there is infrastructure here, see, maybe there is some infrastructure here which can take a picture of this parking lot the way you are seeing it, right? Now, when I give you this bird's eye image, you know that there is parking lot here, parking space available here. But if you are a driver who is entering here, who doesn't have this global picture or the bird's eye view, then you have no idea that there is parking available here, right? But you can have a camera which is giving you this bird's eye view image, and that is available, let us say, to the vehicles through communication. And as a result, you have an algorithm which says, there is a parking slot here, so it will drive you directly to that place. Okay. And when you get to that place, see, parking here may be very easy, but parking here may be quite, difficult. Okay, parking it properly, parallel parking is quite difficult. So today, they are, using what is called as fully automated parking to help the drivers. Okay, so like this, and this requires all these deep learning technology. Okay, so deep learning is a technology that they will use in detecting all these things, locating a parking lot, then guide the driver to the parking lot, I'm sorry, parking space, and fully all this requires this deep learning, right? And remember, everything is real time here. Okay, the input images must be procured in real time. Then your image processing has to be done in real time. The learning has to be done in real time, and any safety precautions that you need to take. Okay, there is a standard called ASIL, Automotive Safety Integrity Level, ASIL. So you have to maintain that standard, and then you have to render the output images for the driver. Okay, so all this is end-to-end real-time. Okay, so it requires very fast processors which are available today. Okay, so I wanted to show you one processor called Jacinto 7 that we introduced for the purpose of this automotives. It's very popular. I believe a number of companies use our Jacinto 7 processor. And just to give you an idea of what is inside the processor, you can see, one single processor has so much inside it. It has got there are two of these ARM A72 processors, right? And then there is four of ARM Cortex R5 processors. So there are 6 processors already. Plus then there is a C7X DSP with this this memory accelerators, right? And then there is this 2 more DSPs for image processing, right? And then there is a 3D GPU, okay, possibly to perform more signal processing. Okay, so you can see that there is a whole lot of processing now available on a single chip, and I have not even gone through all these other things. There is there is a memory, on chip memory, then there are Ethernet subsystem, display subsystem. So it's very complex. See, when we learned microprocessors 8085 when I was a student, it was a very simple, at that time we thought it was very complicated. But today it looks like a very simple system. Okay, today the embedded processors are extremely complicated, right? And remember why I told you about how we cannot keep everything on. We can't clock everything at the same time, and the power dissipation will be too much. So we only will turn on whatever is required at a time. Okay. So I just wanted to show you this to give you an idea of the kind of systems that are used, or the processors that are used. Why are so many of these required? Because you need all these image processing, right? Real-time image processing, which I was telling you about. So if multiple cameras are bringing images and you have to do multiple images processed at the same time, you will need at least 2 DSPs working concurrently, and there is one more C7X to help. So at least 3 images could be processed at the same time, and maybe these can also do some of that, right? So this is an architecture they came up with. Okay, and how did they come up with this architecture? Why did they decide that 2 of these are enough and 4 of these are enough? Well, I suppose they looked at a number of performance issues and power issues and cost, everything they kept in mind, and they came up with this architecture. Over a period of time, these architectures will evolve, and maybe you will have more processors in the future generations, right? So you will have to keep observing how these architectures evolve. Okay, so feel free to go online and look at this Jacinto 7 a little bit more in detail. Okay, and this is how this surround view system works using that Jacinto processor. There could be a number of cameras, maybe up to 6 cameras, and you have to bring images from 6 of these cameras, and then use a deep learning accelerator inside to quickly combine the images and come to some decision about what to do next, right? So very complex. Functional safety, I told you about the hundreds of processors inside a car, ECU. Okay, this electronic computing unit. Okay, that is what I believe ECU is, right? So they call it ECU, but basically it is you can think of it as a single board computer using one of the processors, and there are hundreds of them, right? And 100 to 200 million lines of code, and the features supported include all these. I think I mentioned some of them, right? And this is the new thing that is required in electric vehicles, right? All right. And safety is very important, isn't it? See, we are using so much of electronics, right? And in the early days, you see your mobile phone. What is the duration for which you will use a mobile phone? Maybe 3 years. Okay, after that you will possibly get rid of it and get a new cell phone. 4 years, 5 years maximum. But cars are not like that, isn't it? You will use a car for maybe 10 years, 15 years, 20 years, etc. Then maybe not the same person, but the car will continue to live a longer life because you may sell it to somebody else and that person will continue to use it. But electronics cannot be guaranteed to live for 10, 15, 20 years, etc. So there will be always some problem that can occur. Okay, so the car vendor who sells you a car, now that so much electronics is being used, so they are naturally worried. What if the electronics goes bad? Okay, some fault develops, and then who is responsible? Okay, so you require some fail safety. That means even though there is a failure, can we sort of tolerate that failure and have some sort of a redundancy in order to uh, still continue to operate, or at least do something in order to prevent a major accident from occurring. Okay, maybe if you are, let's say it's an autonomous car, and if there is a failure that has been detected, then at least give the chance to the driver to save the day. Okay, so things like that. So once upon a time, functional safety was only in industrial microcontrollers. They used to worry about it, but now it is now a mandatory thing in cars because we are talking about so much electronics in the car, right? And today we talk about these mixed criticality real-time systems because not every failure may be fatal. See, if let us say a window, we cannot raise, some fault occurs in that processor, which is responsible for unrolling that window up and down. It may not be such a fault that it causes an accident or something like that. It may not be true. But if something happens in the engine, if the engine catches fire, obviously that's a very big problem. Right? So not every failure is very critical. Right? And as a result, we have these mixed criticality real-time systems, and it's a big topic by itself. Right? And timing of safety critical systems must be guaranteed. We must be able to take a decision within a short amount of time. It must be guaranteed that if an engine catches fire, within a certain amount of time, a response will be provided. The car manufacturer has to give that assurance, right, that some action will be taken within a certain amount of time. Otherwise, people will be hesitant to buy such cars. Okay. The other thing that is happening is that within a car, there are, I told you about so many ECUs, right? For doors, for windows, interior lights, everywhere there is ECU. Okay, wipers, lights, okay. And today they use this Ethernet or CAN, okay, control area network or Ethernet, and these are cables, these are wired interconnection networks. Okay? And apparently there is almost 3 to 4 miles of cabling. Okay, it's huge. It's what is the concern there? One is reliability. If something goes wrong in these wires, something happens here, then detecting where the problem is, etc. These are all concealed, isn't it? So to figure out and repair this will be very difficult. Okay, so that is a problem. And also they will occupy a lot of weight. And when the weight is high, the efficiency of the vehicle comes down. So they are trying to see whether we can replace these with wireless communication. So don't have all these wires going around. Instead, use wireless communication to establish this network. Okay? So all these protocols could be soon replaced with this Bluetooth, low energy, or other wireless protocols. Okay, so that is a hot topic today, and as students and young engineers, you should know about these new topics. So the problem is how to establish that network. So there is a concept of auto addressing, right? TI developed this scheme. So when somebody turns the key on, right? When you start the car with a key, then a network has to be established. The wireless network has to be established in a very short time, maybe a few milliseconds, 100 milliseconds or something like that. So when in the absence of a wired network, how to establish that wireless network, that requires auto addressing, and that is a good topic by itself. So electric vehicles. So here are some questions for you. How many moving parts does an EV have? Compared to, let us say, a automotive, which is based on the internal combustion engine. See, inside internal combustion engine, there are so many moving parts. How many moving parts are there in the electric vehicle?
So guys, question, yeah, compared to a petrol diesel powered car, how many moving parts that the EVs have? I can see Vinay is telling 267 and Abdul is telling one.
No, you are far, you are far. There is only one moving part, that is the motor. That is the advantage of electric. The electric vehicle has only one moving part, right, which is the motor, and that is the advantage. So what is the advantage of having fewer moving parts? The advantage is the maintenance comes down significantly. Okay, so you don't. What about these? If you have had a petrol-based car or diesel-based car, you will need this oil change periodically. Do we need that in electrical vehicles? No, because it is based on an electric motor. Do you need filter replacement?
Yeah.
No. Do you need an exhaust system repair? No. Do you need a fuel pump replacement? No. None of these are required. Okay. So
sir, I'm seeing people are our students are telling the similar answers here. Bimal saying lesser mechanical failure, and then Rishabh is telling less wear and tear. No wear and tear in electric vehicle, says Abdul, right? So I'm seeing them saying similar answers.
Very good answers, correct answers, right? So that may be the reason why electric vehicles are getting more and more popular. Of course, governments are interested in electric vehicles for a different reason. There is pressure on all countries to bring down the emissions, and electric vehicles can bring down the carbon emission in a big way. So I think this shows the number of electric vehicles I think sold in India, both these two-wheelers, three-wheelers, and four-wheelers. You can see that fairly significant amount of growth is there. Unfortunately, what happened is, you can see 2017 to 2018, there was a 50% increase in the sales of electric vehicles. And next year it was 23%, and then boom, minus 26%. And you can guess what the reason was, right? What is the reason? Why did what happened in 2020 which caused such a reduction? You would have guessed it correctly, the pandemic, right? So
yes,
they could not.
Yeah, almost I'm getting half a dozen answers. Gaurav's, Sri Krishna, Arvind, Yamuna, Abhilash, Naveen, Nishan, tons of them are giving right answers. Pandemic or COVID-19 is the right answer. Yeah, thanks, guys.
Correct answer. So the production was not there, so they could not supply. Right. Today also that is a problem. Electronics is in short supply. Right? We need a lot of electronics in these cars, and production of semiconductor is worldwide. They are facing that big problem. Movement of chips from China, and I think dependence on China also. You know how politically there is a problem, right? They are trying to possibly become more self-reliant than depend on China, etc. Those things are also there, and also shipments from China, etc. May have got affected because of COVID. So there are so many reasons why semiconductors are in a short supply. And this may also be interesting to you as to which states are adopting electrical vehicles more and things like that, right? Of course, Uttar Pradesh looks big because it's a very large state by itself. So it has shown 26% of the total number of registered vehicles in India are in Uttar Pradesh. Okay. All right, let us look at this. In a electric vehicle, what happens to the fuel tank? The fuel tank will be replaced by a battery. Okay, there will be no fuel
Yes, sir.
tank. Instead, we have a battery.
Many of them are telling the same answer, sir. I could see Sudarshan, Arvind, Naveen, Kishore, Afsal, Muhammad Ibrahim, Anil, Akriti, Tapan. Great. Very happy to see your answers. Yeah, go ahead, sir. Please.
And the other things like what about the fuel station? Instead of a fuel station, you will have a charging station. Okay, so you will need charging stations, and so it calls for a big change. See, the usage model is going to be very different, right? You will need charging stations at regular intervals. Instead, just like we fill petrol today in petrol stations, we'll need charging stations. And what happens to IC engines? No, there are no IC engine. Instead, it's an electric motor. The carburetor will be replaced with a simple embedded processor or a controller. The alternator will get replaced by a DC to DC converter, and there is no smoke control. So there is a big change. Okay, so that is something that you need to remember. Okay.
Great answers, Gaurav, Tapan, Kishore. Everybody is telling the right answer. There are asked two questions also. Great to see the answers. Even Rishav, Sri Krishna. Very good to see the answers as Sir is explaining how the conventional vehicles are different from electric vehicle. Since Sir is not able to see the answers, I'm just reading on your behalf. Thank you, sir. Please proceed, sir.
No problem. So see, in the conventional vehicle, there is this powertrain, right, which channels the power from the engine to the wheels, and the transmission will have the two things, the gearbox and the clutch, and it transmits and converts the power from the engine into what is called the twist for the wheels, right? And the role of the clutch is it engages or disconnects the turning engine from the gears as they are shifted up or down or into the neutral. Okay? Whereas the gears, they are meant for optimizing the engine's power, right? There are maybe multiple gears, first gear, second gear, third gear, etc. And depending on which gear you drive in, if you drive in the first gear, you will be dissipating more power, more energy. And I think the performance gets better when you drive at a higher gear. But then the vehicle, the road conditions and traffic conditions should allow you to drive in higher gears. So this in the old cars, it used to be all manual control of which gear to drive in. People had to use stick shift driving to change the gear. But in these modern cars, I think everything is automatic, and in electric vehicles, it is even more easier to manage that. So when you migrate to an electric vehicle, see, you will need this source of power in order to charge the batteries, right? So see, there is a high voltage battery. See, this 400-volt battery, lithium cell-based battery. Number of lithium cells are joined together to form such a high voltage battery. Why do we need? I'll tell you why. I'll ask you that question. Why 400 volts is required, right? And we have to charge this heavy battery, right? That is the whole challenge here, right? And that battery will use, there is an inverter circuit which converts that into this AC, which will drive the motor. Okay, so that is how it works, right? And there is an opportunity for various kinds of microcontrollers to sort of do the charging control. See, this charging, see, it is not an easy thing to charge such a high voltage battery, right? Because if you charge it very fast, okay, the amount of charging current that you pass through the battery, if it is very large, what will happen? The power dissipation in this battery will go up like anything, right? And when the power dissipation goes up, it will become hot. You may have observed this when you try to charge. I'm sure all of you have experienced these reusable batteries, right? Rechargeable batteries. When you recharge them, so much of power, they become so hot. And here you have a 400-volt battery being charged, so it is going to become hot. And if it becomes too hot, what do you think will happen? There can be a fire accident, isn't it? It can cause a major problem, right? And that is what everybody worries about, isn't it? We are having an electric vehicle where instead of gas, we are using a battery. So this is the safety part. We are very scared that there can be a fire hazard here. Then what about other parts? We also need power for all the other internal electronics. Okay, this high voltage is required for driving the motor, but for all the electronics that is inside, those camera, processors, and all that, we don't need such high voltage. We need smaller voltages. So that is why you need this high voltage to low voltage DC to DC converters. So these are some power electronic circuits that are required, which convert from 400 volts to 12 volts, right? And from 12 volts, they may be further converted into smaller voltages, right? And you can see the amount of power that we are talking about. This onboard computer may dissipate anywhere from 3.3 to 22 kilowatts. Huge. The traction inverter may consume for about 300 kilowatts or something, whereas this one may consume about 95 kilowatts or something like that. And there are very strict guidelines, okay, from standards bodies on all these how to charge, what kind of safety precautions have to be there for the this motor driving, and there are some standards for this DC to DC converter. For everything there is a standard, right? So those who work on this automotive electronics or automotive software, see, one big thing is they have to comply to all these standards, right? Because the automotive manufacturers, see, they are under pressure from the governing bodies to maintain certain standards, because obviously, isn't it? In the same way, they put pressure on the electronics semiconductor manufacturers and software providers to comply to these standards. So there are a number of standards like ISO 26262, and you should just know about some of these things. Okay? So why do we need such large batteries? See, if you use a smaller battery, then unfortunately, its range will be limited, isn't it? Small batteries will limit the amount, how far can you travel, that will limit it, because it will not maintain much charge. And that is a worry that everybody has, isn't it? That is called as range anxiety. That means when I buy an electric vehicle, everybody worries, hey, what if I get stranded somewhere where there is no charging station, and how far can I go with this, etc., etc. So they worry about that. But if you have very large batteries, you are making them expensive, number one, and they are liable to those fire hazards, etc., and not environmentally friendly. And see, if I'm in a car where there is a 400-volt battery somewhere, this can kill a human being if you are not careful, right? So there has to be a lot of isolation. Okay, So this high voltage and low voltage have to be properly isolated so that the drivers, etc., and people inside the car are not exposed to these large voltages. Okay? So there are a lot of functional safety precautions that we need to take, right? And in future, they claim that there may be a deployment of what are called as charging roads. Okay, so there will be some wireless charging systems installed under the roads. Okay, and that will allow the EV to be charged while driving. So this is a futuristic thing. So maybe it will come in the future. And okay, I'm getting, it's already 8:40. Let us see. I'm telling you a little bit about some of the microprocessors and microcontrollers that are, used in this electrified powertrain. I told you about this powertrain, that is transmission, gearbox, clutch, etc. Now that whole thing is, now it looks like this. Okay, so from the power grid, the power that is coming, the three-phase power that is coming in, has to be converted to DC, right? And that is drives a generator which drives that engine, right? So this is for this you will require a processor, and a real-time microcontroller is required to control the speed and all that. Then there are this high voltage to low voltage DC-DC converters that I told you about. Those also require some processors, right? And there are other the high voltage battery charging has to be controlled, right? So this charging of the battery, I think I mentioned to you that you need proper algorithms for charging the battery. And it will be a very complex algorithm because it has to constantly monitor the temperature. If the temperature is going very high, then you have to reduce the amount of charging or stop the charging, and then resume when the temperature becomes more safe and things like that. So it's not just going to be a simple charging algorithm. Okay, so you have to remember that. Right? And you may have heard about some of these softwares like AutoSAR, and security is also nowadays a big concern. And I think I have a slide on that coming up. So the battery management system is the heart of the computer now. See, this charging of this battery is a very big thing. Okay, it's called BMS, or battery management system. And inside that 400-volt batteries, they would have many individual cells. So maybe 100 of them would be packed together in series to create a higher voltage. And some of them may be in parallel because they have to supply more current. So it's a very complex system here. Okay, it is not so simple. Okay? And unfortunately, these lithium ion and this I don't know what PO is, some palladium or something like that. These lithium palladium cells, they can get damaged or overheat during either overcharging or over discharging or over temperature operation. So you have to intelligently control the battery charge to protect it. Right? So you have to have a way to sense the voltage, the current, temperature, and any wear of the battery cell. So it's a fairly complex algorithm. In addition to that, you may have to monitor the faults, isn't it? I told you that when you're driving, some electronics may malfunction, something may go wrong, and you have to constantly monitor the faults and warn the driver and take suitable action. Okay. And you may also have to monitor how much energy is still remaining in the batteries, how far can you drive. See, today we are used to watching our gas, how much gas we have or how much petrol we have, and there is a meter that shows us, how much is left. But in the battery, how much charge is left, it's up to us to gauge. Just like in your mobile phone, it shows you 100% charged and 50% remaining. Something like that will have to be available in the car as well. And the battery may have to be replaced after it gets charged a number of times. Maybe after a couple of years, you have to replace the battery. We are all used to this even today. The battery in the car, we have to replace it every few years. So you need a monitor to display the life of the car and things, life of the battery and so on. So today, I think a hot area is this wireless battery management system, right? So presently, it's all based on wires, but I think TI is trying to popularize this wireless battery management system. And once you reduce the number of wires, I think they have not reduced it to zero. I think they have reduced it to, I think, 1 or 2 wires. Okay, you will still need 1 or 2 wires, but they have eliminated a lot of wires, and that is improving the reliability, and that is improving the reducing the weight. As a result, the efficiency of the, so you can look at the demo. You see, these are all very recent things that I'm telling you, right? I think this was just last year that they demonstrated this. So you will find more information on our. There are some videos, etc. that you will find. Okay. And TI is also working on the charging station electronics. See, there is a lot of electronics required in the charging stations, right? The charging must be quick, affordable, and safe and robust, right? And the infrastructure must be able to generate and store and transmit and distribute, power, which is going to be crucial for the electric vehicles. When I say EV journey, I mean the, how they will be received by consumers. Okay, unless these charging stations are going to be as easy to use as today's petrol stations. Imagine if there is a long queue because the charging is taking long, etc. People will complain. Okay, so you need fast charging, you need safe charging. Okay, so I think one technology that is coming there is gallium nitride technology, right? And the electronics that is used in these charging stations, more and more of it, they are trying to use the gallium nitride technology because it will allow this faster and more efficient charging. Okay, so this is a thing that you need to know. Okay, this is like a some general knowledge that you need to know. And the semiconductor requirements in electric vehicles will be very special, right? You need a very high quality in these electric vehicles because any fault that develops can be, it can cause a major problem, right? So we need high quality. So DPM stands for defective parts per million. So when we supply parts to a customer, right? Maybe there is a car manufacturer that is buying semiconductor from TI. So we have to maintain that for every million ICs that we supply, not more than a certain number of them will be defective, right? And you may be wondering, why should we be supplying defective parts? It is not that intentionally we want to supply defective parts. It's just that sometimes defects are there and we are not able to find. Okay, these are so complex systems. I told you, right? Look at this. Look at this. Look at this system. This is a chip. This is a single system on a chip. How do you test it, man? I mean, how many faults can there be in this chip, right? So it can be quite difficult to ensure when we sell one of these that it is fully defect free. We try our best, right? But there is that one in a maybe billion chance, right? That there could be a defect that we have not tested for, right? So auto manufacturers demand what is called a zero DPM. They say, I don't want even a single defect, but that would make it very expensive. Okay, the parts will become very expensive if we have to do so much of testing. Okay, so therefore there is a certain compromise. So today we talk about defects per billion, right? So it may not be zero DPPM, but it may be more of one in a billion or something like that. So they are very stringent requirements on the defect levels in these automotives. Okay. The other thing is safety requirements. I think I mentioned to you already, right, about the importance of functional safety. There are a number of standards that we have to comply right? FUSA stands for functional safety. Some people call it as FUSA or functional safety, right? And reliability is another thing. What is reliability? See, I may sell you a good part, but after a few years, it may go bad. Okay? Then I'm not going to take responsibility for the what happens after maybe 5 years. So I can give a guarantee that maybe it will work for 5 years. But what happens after 5 years is maybe, as a semiconductor manufacturer, we may not want to take responsibility because we have told that the life is only 5 years. So if something happens within the lifetime, then I am responsible, right? I have to own the responsibility, right? So we are very worried that our semiconductors may fail within, the lifetime of the semiconductor, right? So excess testing is done in order to ensure that such things don't occur. And today, there are some stringent requirements. For example, for electrical vehicles, they want the electronics to work without failure for 30,000 hours. Okay, whereas that requirement for IC engine-based cars was about 20,000. Okay, so there is a more stringent requirement. And I think security is a big issue in cars, right? You may have heard about hackers who are, see, because we are now saying cars are connected, right? Cars are connected to other cars and things like that, and wireless communication. So people can misuse the opportunity to hack into a car or intentionally cause the car to malfunction and things like that, right? So there are a number of these wired and wireless networks that are inside a car, right? In a single car, you may find CAN, Bluetooth, GSM, Wi-Fi. All these are present inside the same car, and they can be hacked into, right? And as a result, people can, make cyber attacks on these cars. Just like you have heard about cyber attacks on computers, right? Ransomware and all that. In the same way, somebody can take over a car and demand ransom in order to release that car and things like that. So people are very worried about those things, and lot of safety features are security features are being introduced in cars in the systems manager. I think this is a good time for me to stop. Okay, I have about 8 minutes left, and if there are any questions, you are welcome to answer a question. If I can answer, I'll be happy to answer, right? And I believe maybe there is some quiz or something that they want to organize. Any questions? I think I'm not able to hear you, man. Are you muted or something?
Okay, okay, sorry. Yeah, I was muted. Okay. Am I audible, sir?
Yeah, you're not audible.
Okay. Guys, there are a lot of questions about, I'm seeing people asking about sharing this particular slide deck that Sir has shared today. No worries, we'll collect it from Sir and we will email you, next week, one thing. Second thing is people are asking about quiz code. Give us some time because there are some questions from students. Probably we'll take few questions because in the interest of time, we're almost 8:53 now. Now coupon is ready. I will share the coupon once we take at least 2 to 3 questions, right? So let me read at least some questions also which you can take. So there's a question from Sri Krishna, very interesting question. He's asking how long it will take for EVs to replace the combustion engines.
See, EVs already are replacing, but if you are talking about completely eliminating IC engines and completely replacing with electric vehicles, I think it may take many years, and I'm not sure whether they'll completely replace anytime. See, they may coexist, at least for many years. They will coexist. But if we are successfully able to use solar to charge the batteries, and as a result, electric vehicles become cheaper, see, people, economics ultimately drives everything, isn't it? So if electric vehicles become cheaper than the other cars, which will happen possibly after many years, then definitely, people will switch by themselves. They don't have to be told. Today, electric vehicles are more expensive, and charging stations are not as many, and as a result, people are still, not switching so easily. But the trends are that many people, and policies are also helping. So I think the government policies are also there. Maybe government will put pressure on certain sectors to switch to electric vehicles in order to reduce their carbon emissions and things like that. So all these policy decisions also will possibly help in shifting to electric vehicles. So I think it will take many years, maybe 10, 20 years before we can see a very significant amount of electric vehicles, and they replacing with the ICE vehicles.
Okay, so at least 2 decades. That's what sir is telling. So
Yeah,
that there
yeah.
are
I mean, a lot of innovation is happening to reduce the cost and things like that, and that is the space that is wide open for you people to work on.
yeah. So next 2 decades, utilize this opportunity and build your career. That's what sir is trying to say.
Yeah,
Because
yeah.
so many.
Automotive is a big market. Okay, because a lot of big players are entering, right? Earlier, see, think about it, guys. I mean, car manufacturing was considered the Germany. Only some of these used to do it. Now, you can see Google is entering that, Apple is entering. So Silicon Valley, is now becoming the place where cars are going to get manufactured and so on. So that's a major, major shift. Any others?
Yeah. Second question. There's a question from Abdul Qadir Jilani. He's asking, important thing is in EVs is charging, doing the charging in less time. How TA is working on this?
I told you, right? There is this battery management system, and we provide solutions for that battery management system, including that wireless battery management. BMS is the main thing. Okay, there, what you call as charging, I think the overall term that is used is battery management system. So my suggestion is, please go and look at what solutions TI is offering for battery management system. Entire solutions are there. See, it is not one chip that will be offered. It will be a whole system. Okay, it includes many microprocessors, power converters. A lot of these things are required in this battery management system. So it will be a complete subsystem. So please go and take a look.
Yeah,
It
yeah.
is available.
And another question from Arvind is asking, sir, if Li-Fi possible for vehicles to go to vehicles communication at night. He's talking about Li-Fi, Li-Fi.
Li-Fi. Oh, okay, okay. I haven't come across Li-Fi being used for car-to-car communication. I have seen that mostly used inside malls, shopping malls, and things like that. I have not come across Li-Fi being used for vehicle-to-vehicle communication. I don't know. I don't think so.
Okay, okay. So one more last question, sir. There is a question from Ajit. He's saying fuel engines are more powerful compared to motor. How will we be increasing the power and torque in EV? He's talking about the
Uh,
power, right?
I think these electric motors are very efficient and they can work at very high speeds, right? So I don't think that you know, I don't think I have ever come across a statement which says, speed can be a limitation in electric vehicles. No, that is not the case. These electric motors, they can, work at very high speeds, right? And anyway, you see, the vehicles speed limits are there, right? You cannot drive, at, even though I think in some places like Germany, I have heard that there are some places where on the freeway there is no speed limit. But I think whatever is being offered today by the conventional cars, electric vehicles have no limitations in terms of speed that I am aware of.
Okay. So thank you very much. I think we need to stop questions because a lot of questions
Sure.
are there. Unfortunately, in the
Okay, so
interest
I'm
of
back.
time.
Yeah, thank you guys for giving the opportunity, and wish you all the best. Hope many of you may be able to work in this space. There's the opportunity for you in software, electronics, systems, so many places you may find. I think it'll happen. Many companies will possibly come in the near future, maybe next 5-10 years. So I'm sure you will all get opportunities.
Okay. So in the spirit of Emergence, and also on behalf of Emergence students, interns who are attended, we want to thank you, sir. Thank you for this wonderful, right from I keep on taking notes, ranging from all the way from 3 I's, the instrumentation, interconnection to intelligence. You went into complete into the processor architecture and everything. I think it's a pretty vast topics that you've covered. It's been really, really overwhelming. And we want to thank you on behalf of all of us here in this webinar, one thing. Second thing, in the spirit of Emergence, we always ask this question to students who are attending the webinar. Can you tell me one thing that you have learned from this webinar? I know you learned many things. Can you tell me one learning so that we can read through and then also gets a reciprocation, right? We spend so much of time. We also share in what did we learn. Go ahead, guys. What did you learn? One point so that I can read out and yeah, EV is the future. Then Mohammed says processor architecture. Then Adarsh says insider knowledge. Then charging station. Somebody is selling battery management system. He has learned wireless ECUs. Somebody is selling. It's running very fast. Still so much to learn. That's what somebody is telling. ADAS is selling MEMS technology that can. And then people are talking about avoiding pollution, becoming more environmentally responsible, future technology is what people are telling. And then technology is evolving much more than what we actually think, right? Okay. And whatever sir has explained, if you see just in a simplistic way, it is nothing but IoT, right? Internet is there everywhere and connecting things. That's something, very interesting to see. For me, the most fascinating point was something like when sir said, when you see the wiring inside the car, the length of the wire is somewhere around 3 to 4 million distance, right? The sheer yeah. So that was something, it's something like our industry, not our thing, right? So it was fascinating, and then see how the low power the BLEs are going to replace that. Okay, I think there are a lot of still coming in future of India, EVs and future of coding. And another point that sir said was about 100 million lines of software in this particular EV, right? That's, you can think about the opportunity that is in front of you, all of you, and other areas like, for example, critical problems that we need to solve with respect to battery management, cyber security, and then the AI and ML coming in the deep learning coming in form of the automated parking system. We need to process so much of images to make the systems intelligence. I think the learning is endless from today's presentation. So thank you very much, sir. Thank you very much for your valuable time and sharing your perspectives. Our team will reach out to you and collect the slide deck from you offline, and then we will circulate to all the participants today. Okay. So thank you very much, sir. Can you take the slides, sir, so that we can go with the quiz for today?
Yeah. Please.
Okay. Yeah. So let me come back to today's quiz code because many of you are asking about quiz. Okay. So quiz is already live. Let me just quickly show you. If you are following the Instagram, Emergence Instagram, you go here. It's already live. The important thing is you need to put the code here, the coupon code. So the coupon code, I'll share it in the screen now. You can see the code S1W1 DRCPREV. So I put it in a simple word, right? Series 1, webinar 1, Dr. CPR, right? DRCPR and EV, electric vehicle. In case if you're not able to copy, let me also upload in the handout section. Give me a minute. in case you're finding it hard to read that. Let me upload that. So if you see that there is a section called handouts, you will see a file there called quiz code. Are you able to see that, guys? Quiz code. Folks, are you able to see that quiz code file there? Okay, great. And you can see that there's a handout in your right side, right? You will see that. Anyways, it's there in the screen also. You can take down and take the quiz. We'll keep it for another 2-3 hours, not a problem. Some of them have taken a screenshot. That's also great. Because we want to ensure that you guys take it up, right? We don't want anybody who's not attended the webinar to come and take up this particular quiz and then get the prize also. Okay. So next week we'll announce the winners, and also the certificates will reach you, and the slide also we'll get it from sir, and then we'll ensure it reaches you. Okay. So that's about it for today. And this is another email, and in case you have any queries, you can email us at text_events_manager. Is where our team, we created an exclusive email ID for this. There's a phone number also in case we have any questions, queries. We are planning to host at least a month, one seminar, one webinar like that. So watch out for our our social media mainly, and anyways we'll also send out emails in the groups that we are already part of. We want to do at least one masterclass webinar every month. If possible, we'll make it into 2, right? So that's coming from our side to bring in more experts like Dr. C.P. Ravikumar as we move forward, right? To start with, we want to keep it technical in nature. Probably then after some time, we'll shift it to a little bit on the softer skills and career building and stuff like that. Okay, so that's going to be the plan for us from our side. And as you know, our LinkedIn and our Instagram page. In case if you're not following, you can go ahead and follow that. And last but not the least, I want to thank you for all of you for being patient. I know it's like past 9 p.m. For attending this particular session. I know it's Saturday night. It's not easy to be stay up until almost like I can see full house, right? Almost like 350 people plus stayed throughout the session. Thanks for making this interesting session very interesting, sir. Making it more relevant for the students, and also the interest that shown by all our students has been phenomenal. Like, I've been inspired. Our team, Emergence team, is really inspired. Can I get some quick feedback? How did you find the overall, the way how this today's webinar went, the planning, the communication? How did you guys find? Many of you are telling thank you, very good. Rich in content, says Uma Shankar. Awesome, says Arvind. Good and informative, wonderful webinar, very engaging, excellent lecture and host. Informative session. Please share the quiz link already shared. Very interesting and knowledgeable, wonderful. Got a view of the domain, new domain, says Abhilash. Some of them are not there in Instagram. I don't know what to do about that. I thought you guys are youngsters or young people should be in the Instagram, because we also want to make it easy other than creating some login and password. We'll try to see if we can make it available for non-Instagram users also. Okay, and then we got to know about so many things. And then hope it's fine. Can you provide recorded version? Yes, we'll also send the recorded version as well as the this PPT from sir. Both it will reach you in the next week. Early next week or mid of next week. It will ensure it reaches, right. Abhilash says never knew it was 150 million lines of code. That's amazing. Okay, a great session. Thank you, sir. Says Jayant. Explained with real-time application. It is easy to catch. Says Usha Meena. Recorded session, Siddharth, will email you. Okay, it will put it in YouTube. We'll make it open for everyone. We'll give a YouTube link. We'll put it in email and send. In case if you're not getting the email, you can watch out our channel in YouTube. Okay. And then thank you for the really informative. Again, Ala says to see you again. Thank you, Ala. Mohan is telling very nice, useful. Thanks a lot for conducting. Says Siddharth. Please share slides if possible. Yes, Anil will share you. Awesome session, says Nishant. Okay, so fantastic, guys. Glad to see so much of feedback. I know it's Saturday night, staying up and then attending this session. It shows your interest, and as sir said, with so much of challenge coming around EVs, right? It's an excellent opportunity for all of you to build career for the next at least 2 to 3 decades. There are so many challenges that need to be solved, right? So wish you all the best, whether you are a student, intern, or a newbie who has attended this particular webinar. Looking forward to see you in the next edition of webinar, in March. Okay. So thank you very much, Ravi Kumar sir. Thank you very much, all of you, to participating. So until the next edition of webinar, take care and bye-bye.
Okay, good night.
Yeah, thank you, sir. Thank you very much.